Now let's welcome Mr. Dekker.
At the TASS 2021 Sustainable Energy Forum. My name is Harmen Dekker. I am Director of the European Biogas Association, and I've been asked to speak about renewable gases and what the situation is within Europe and how this can be maybe implemented also within other regions within the world. So let me start my presentation. We have arrived at crucial times. At the moment of this recording, the COP26 is in full swing. And we need to make a real impact to make sure that our children have a future. Our climate is changing too rapidly, and we need to make sure that the CO2 is within certain limits. One of the ways to do that is to make sure that we use renewable gases. And today, I'm going to focus together with you on biogas and biomethane. To some of them, some of you, it might be known, but a lot of you might think, well, that might not be such a big solution for the future. Actually, what I'm going to show you is that we can fulfill a huge impact within the society in various ways, and also making sure that this is a solution which is scalable and sustainable, and actually also available today. First of all, I would like to show you a few things what is happening within Europe with regard to the movement towards a Green Deal. As you know, or probably know, that in the past years, Europe has been embracing the need for quickly change to renewable energies. And although it's not even going fast enough, they are making impact. And there are a few items where they are making a lot of impact on. Just to pick a few out of it. They would like to move to sustainable transport, and I will touch upon that later in this presentation. They are also all about, of course, which is the framework of everything, achieving climate neutrality. That, of course, needs to be financed in a just way. We also must make sure that everybody can afford it, so it is a just transition. And also, what is important is it must be a circular transition. So let's have a look on what then the place is of biogas and biomethane inputting. First of all, for those who do not know, biogas is a product which comes from digestion of waste and wastewaters and other feedstocks. Basically, in an anaerobic environment, biogas is being produced. And biogas consists of a large portion of CO2 and a portion of biomethane. Normally around about 45% CO2, 55% of methane. Now, the methane part is, of course, a fuel. We all recognize that from the fossil natural gas, which is abundantly available in many places. Now, the CO2 part is important to mention as well. The CO2 part is of biogenic origin, meaning that within 1 year, a plant, for example, is taken up the CO2, and then within a biogas digester, CO2 is being released again. That means that within 1 year, you have a short cycle. This is not seen as a contributor to the CO2 emissions because the fossil fuels are being seen as contributing to the total emissions. Important to notice. However, the good thing is we can do something smart with this CO2 as well and liquefy that and use that within our food and beverages, but also in the heating and the cooling, and also within various other applications. So that is biogas. Now, if you take out the CO2 and you are left with the methane, we call that biomethane. And that can be used for many other purposes, like transport of cars, trucks, maritime industry, heating of buildings, for example. Now, basically, biogas is based on 4 pillars. One is it really is embedded within the environmental change we are going to make. This means that the environment is positively affected when biogas being put in place in the right way. Sustainable fuels can be made from sustainable feedstocks. At the same time, we can actually increase agroecology by implementing biogas. The digestate, which is a leftover of the digestion process of making biogas, can be reapplied back to the land and fertilizing that again. When we fertilize it, it means that we do not have to make use of chemical fertilizers, also called mineral fertilizers. And as you might know, mineral fertilizers creating a huge amount of CO2 emissions by the production of it. So there are multiple advantages by doing this to the environment. But it also provides, on the left-hand top corner, economic growth. It provides growth for the agriculture, growth also for the industries. It is a renewable form for transport as well. It is important to make sure that when we are designing any renewable fuel, it is making impact also for economic growth. Then there are 2 other aspects I would like to touch upon as well, is the social well-being. We must make sure that if we are putting anything in place, people can still have the jobs, can have look after it. It is affordable and a just transition. And at the same time, of course, this is the whole goal we are going to do that, is changing the air and the climate to the better. Now, when we are looking at how biogas and biomethane is to be used, then in Europe we have done a study on how much biomethane, sustainable biomethane, could be available in 2050. That is around about 1100 terawatt hours, and I'll come back to that later in the presentation as well. Now, within Europe, we have the advantage that we have a large gas infrastructure for the fossil gas. So it means that we can use that actually. We do not have to invent anything else. We can use the infrastructure together with maybe in future, if all goes right, green hydrogen. So we have then 2 renewable gases. One is green hydrogen, and the other important one is biomethane. And by using the existing infrastructure actually within Europe, we are going to save 217 billion euro on an annual basis. Now, I would like to show you a few examples on how this works. And I would like to have a look at the circular city approach. I would like to also have a look on the buildings, what we just did on the gas network, and on transport. Now, circular city is something very interesting and maybe something to start up immediately in various cities around the world and also within Taiwan. Because a city is producing waste. Whether you like it or not, we have waste. We need to sort our own municipal waste in an organic fraction as well as a fraction which needs to be looked at a different way. But the organic fraction actually we can use to digest. And if we're going to digest that, that will mean that you can actually produce biogas and thus also biomethane. This means that actually your waste can be used within your city to propel, say, localized or municipal traffic. Or maybe it's going to be sent to the homes to make sure that your homes is being heated, or to the industry. This plays a very important role to make sure that our waste can be treated as best as we can to make sure that we have renewable fuel available at the same time. And this is just a perfect example on how biogas and biomethane is playing a crucial role in our future. And then the last part, so we looked at the buildings and the savings and the use of the gas infrastructure, the savings within Europe, then of course 270 billion euros. Then the circular city approach where we can propel our bus and trucks and cars, but also our houses. But now have a closer look at the transport sector itself. Now, in this way, we can have a look at cars, trucks, but also the maritime sector. Now, of course, we all know that if we are using diesel or gasoline, that this is producing a whole lot of CO2 emissions, which is adding to our total CO2 in the atmosphere, which we need to avoid. Now, so this is the total positive, as you call it. You have a lot of emissions. Now, in Europe, they said, okay, we do not want that, but we will only look at electricity. We would like to have only electric cars, which is good in itself if those cars are green and the electricity is being green as well. But when looking at the cars, they are saying that all electric cars have a zero emission. And how they look upon that is in this way. Actually, the industry, say the electricity production, is not going to be looked at. No, the cars and how we propel our transport is being looked at as a zero emission when you're producing electricity. Knowing that only within Europe 20% of the electricity is green, this is not true by nature. So it's always good that when you're implementing regulations, you look to how the fuel is being produced, whether it's electricity or biomethane or other fuels, till the very end how it's being used. And if you do that, and if you then look at, for example, biogas, and you look at the total production, how we can produce that, then actually we can achieve negative emissions. How does that work? Basically, if you have waste, or if you have manure from chicken manure, cow manure, that is producing a lot of methane emissions itself. And at this moment, we do not capture it. That is going into the atmosphere, and methane is a very potent greenhouse gas. By actually capturing it, we avoid the methane emissions going into the atmosphere. And when burning it, it will be CO2 instead of methane, so there is a lot less effect on nature. And the effect of biogas and biomethane can be so great that you can have actually your negative footprint, meaning you're actually taking CO2 out of the air. Now, biogas and biomethane is also a fuel which can be used very well within the transport. If you look at the very bottom of this slide, you see gasoline having a certain amount of space needed in your tank, in your car, be it truck or within your ship. And the closest fuel which comes to it is actually LNG, with a similar structure on energy density. So if you actually are producing biomethane, you can produce it as compressed form, then we call it CNG, compressed natural gas, bio-CNG, or you can actually liquefy it and make bio-LNG. So meaning that actually we do not have to put in a lot of different infrastructures to make sure that this is going to happen. Neither the trucks needs to be a lot bigger to allow for a great fuel tank on its back. Now, those are a few examples. Now, I would like to have a quick look with you on how we can grow the biogas and the biomethane sector and how we did that in Europe. And maybe this can also be an example in other countries such as yours. Over a period of 2009 to 2019, we have been producing just a little bit less than 13,000 new biogas plants. Most of them are actually producing only biogas and not biomethane, but they are producing renewable electricity and heat. So this is a very good example that within the right measures taken by government, and I'll come to that a little bit later, you can actually make sure that you can produce a whole lot of renewable energy. And the message here is we have the feedstocks. It is available. And therefore, we can scale up the biogas production, scale up the renewable gas production, in a very sustainable way as well. So we do not have to wait. It is already there. The technology is there. We can implement it right away. Now, I've been talking also about the biomethane side. So in this slide, you see that in a short space of period, that there are a lot of biomethane plants coming online as well. And actually, this is growing by far the fastest in all scenarios. And at this moment, in 2021, we have more than 1,000 biomethane plants within Europe, and is expecting to accelerate even further, which is needed, as I said before. Now, here we see a variety of sizes of biogas plants. Now, there is a tendency, actually two ways, small ones and a lot larger ones. So those which are now in the middle will probably diminish, and you will have larger biogas plants in the future. Why do we have the smaller ones as well? Because a lot of governments are recognizing that biogas plays a very important role for agroecology, meaning that we can actually revitalize soil, revitalize the agriculture, and actually also allow for jobs in the rural areas. So that's what they would like to support on one way, beside the renewable energy. And on the other hand, we see also that we have a need for some larger plants which can feed into the cities, into the transport, and into the industry. This is one of my last slides where I look into the development of the feedstocks. And interestingly enough, you see here a change in the use of feedstocks. The yellow part is called energy crops, and that is diminishing. The use of energy crops is diminishing for actually one reason. If you put energy crops for the sole purpose to make renewable energy, you're actually displacing land for food and feed. That is not very liked because this is not a very sustainable way to do that. So in all our scenarios, which I've just presented, there is no energy crops within it. Actually, we are producing it from sustainable feedstocks like waste, like residues from agriculture, and like wastewaters. And this is important to know that we can, even with the feedstocks we have, make a great impact right now today by biogas and biomethane. And that has been shown already from various reports within Europe, where we are on the left-hand side, when you see we are currently producing on energy-wise 193 terawatt hours, which is as much as the whole country, Belgium, for example, consumes on natural gas, to round about 1,300, so 11 to 1,300 terawatt hours in 2050, 2040, 2050. That is important because that shows that we can make impact. How big an impact? Well, in Europe, we expect that we produce, or we need gas, anything between 3,000 to 3,500 terawatt hours in future, which means that this part is already 30 to 40%, depending on the total future gas need. Meaning biogas and biomethane is just not small, but when done right, it can make a real impact on the environment, on agriculture, but also on the renewable energy side. Now, within Europe, we have various legislations now being put in place. This is called the Fit for 55, the goal to reduce the CO2 emissions by 2030 of 55% as opposed to the emissions in 1990. So those are all types of measures we can think about to make sure that we go into our renewable energy transition, but also impacts our world of biogas and biomethane. Just to mention a few, don't want to spend too much time on it. If you have any questions, then please do let me know. But those are on transport, but also on the Renewable Energy Directive, so how to be using renewable energy, taxations and the minimum tax, ETS, so the trading mechanisms of CO2. And of course, we are going to look on various ways for the gas package and methane leakage package. Meaning that there is a lot of methane leakages going on, and we need to minimize that as well. And biogas plays a very important role in that. So with all that, I hope I have painted a picture that biogas can play and biomethane can play a very sustainable role and an important role, because gas is needed and we need also carbon, and both biogas and biomethane can actually provide that. So we can develop quickly. And if you need help to develop further your potential or your infrastructure to make sure that this is going to help within the total renewable energy mix, then please do let me know. But for now, many thanks for listening. I hope you enjoyed it. It's a very quick and brief overview, but I hope you do enjoy the rest and the remainder of the conference as well.